And now it's my pleasure to introduce today's presenter, Dr. Carl Haber. Dr. Haber joined Lawrence Berkeley National Laboratory in 1986, and he is currently a senior scientist in the physics division there. As he will explain in today's talk, he's been working on the preservation and restoration of recorded sound for nearly 20 years.
I happened to be listening to the radio. There was a public affairs forum on our local national public radio station, and it was a speech given by Mickey Hart. Mickey Hart is a musician. He's probably best known as one of the drummers from the Grateful Dead, but he's also a very passionate advocate for the preservation of recorded sound heritage. He wrote a book called Songcatchers, In Search of the World's Music, which is a beautiful book, and talks about all the heroes of, say, sound preservation going back to the early 20th century. And the points he made in the lecture, in the discussion, were that sound recordings are of great historical value, and he gave a whole bunch of reasons for that, that there are many of them, and he cited the Library of Congress, where he served as an advisor on preservation, and that these recordings are sometimes damaged, delicate, or endangered, and we don't really maintain the old playback systems for this sort of diversity of formats. So as a particle physicist, thinking a lot about imaging, and particularly noting this point about them being damaged, delicate, or endangered, and not having the old playback systems, I thought to myself, perhaps we could use some of the same imaging modes that we do in particle physics, but instead of looking at images that relate to the subatomic, somehow derive images from these endangered media, and then apply a computer analysis the same way we do to these other images to try and extract the sound. So when you think about this as an imaging problem, it means you want to gather images that represent at very, very high resolution the information stored in those grooves. And such an image is shown on the, say, just to the left, where you see a kind of squiggly white pattern with black highlights. Once you have those features, you can map that into a waveform and eventually format that as audio. And so that was the idea of this kind of image-based approach to restoring audio recording. And then finally, this was the result of our first, say, crude attempt at an optical readout and data analysis. Now, it wasn't just the library. The library was our first collaborator, but we have tremendously benefited by a whole range of collaborations with other institutions. The National Archives and Records Administration, the Smithsonian, the University of California, the Moscow State Conservatory, Harvard University, and the University of Chicago are all institutions with which we have done projects to restore aspects, parts, or even entire collections. I would say very strongly that partnering with the library was the critical step, other than merely demonstrating that this had potential, was the critical step in moving this from a lab demonstration to a real application. Finding funding, it was critical to have credible partners in the field that we were, say, entering into, because only through a collaboration do you really cover all the bases. In the end, you can go to the Library of Congress, you can go to the National Archives, but you have to find a person that wants to do this. And we were super fortunate in all of these institutions that we also had a hero, a champion, a person that really engaged. I often kind of had to pinch myself with how well the collaborative aspects of this project went. The politics and the controversies about primacy and whose idea gets to be the one that's chosen can be pretty intense. While I encountered some of that, it was less than I was used to. This project had, in some ways, shorter turnarounds than the high energy physics projects that I'm used to working on. I'm currently involved in a project where we started kind of looking into it around 2006, and it's not going to be till the late 2020s that we actually collect any data. So while it was a long-term project, it consists of a whole variety of numerous small projects that lasted anywhere from weeks to a couple years that we could do those. And so I think it was no problem. It was constantly exciting, and it was easy to maintain enthusiasm.